In our previous video, we saw these divisibility tests that help us know if a number is divisible by another. And one place that we can use those is if we're asked to find the prime factorization of a number. And prime factorization comes from this idea known as the fundamental theorem of arithmetic. And the fundamental theorem of arithmetic states that every number can be written as a unique product of prime numbers. In other words, we can divide out prime numbers to write factors. Divide out primes to write factors of a number that multiply to equal that number. And it's always going to be a unique list of numbers, up to order. To help us out with this, it's good to know some of the first primes. So the primes under 20 you should have memorized. The primes under 20 are 2, 3, 5, 7, 11, 13, 17, and 19. And there are more, obviously, that are larger than 20. But those you should recognize as prime numbers. And so if you were asked to find the prime factorization of 490, what we will do is we're going to say, what prime number can I divide out of 490? Well, because the last number is 0, I know it's divisible by 2. It's an even number. So when I do 490 divided by 2, I'm going to circle that because that's a prime number, I get 245. That's not a prime number, so I'm going to divide another prime out of it. It ends in a 5, so I know it's divisible by 5. When I do 245 divided by 5, I get 49. And 49 I know is 7 times 7. And notice those are primes also, so I will circle those. And when we take those circled numbers, all of those prime numbers together, those will build the prime factorization. 490 is equal to 2 times 5 times, and because we have the 7 appearing twice, we'll write it as an exponent, 7 squared. That is the prime factorization. It's the only list of prime numbers that will multiply to 490. Let's try one more example. Let's try the number 924. I'll put it a little more over to the side, give me a little more space to work. Well, the last digit's a 4. It's even, so I'm going to divide by 2. That's going to give me 462. Circle the prime. Still even, so we'll divide out another 2. That's going to leave me 231. Well, that's odd. It doesn't end in a 0 or a 5. But if I add the digits together, 2 plus 3 plus 1 is 6. I can divide by 3. So because I can divide the sum by 3, I know the number is divisible by 3. It goes in there actually 77 times. And looking at 77, I can see 77 is divisible by 7 11 times. And both of those numbers are prime. So now I have my prime factorization of 924. We had the number 2 appear twice, 2 squared, times 3, times 7, times 11. And that is the prime factorization of 924. It's your turn to practice some of these and get really good with divisibility test and prime factorization. Let your instructor know if you have any questions.